along to the first talk in this series, a sort of mini webinar series that we have co-hosted by Lancaster University and the University of Sydney. So there are 3 talks. The first today is Professor Monika Bednarek from the University of Sydney, who's going to be talking to us about new tools, text analytics tools, and how these can be applied in corpus linguistics work. So without any further ado, I can pass over now to Monika. So Monika, whenever you're ready. And then at the end of the talk, we'll have hopefully sort of 5 or 10 minutes at least for some questions as well. So yeah, sorry, Monika, whenever you're ready.
Yeah, okay. Thank you, Gavin. And thanks everybody for being here. Hopefully it's a reasonable time for you. I'm just going to share my screen. Okay, so hopefully everybody can see that. Yeah, let me know if not. Okay. So I do want to start with an acknowledgement of country, since I'm speaking to you today from Australia, and in particular, I'm speaking to you from the land of the Gadigal people of the Eora Nation. So I want to acknowledge the traditional owners of this land, and also want to pay my respects to their elders past and present. As Gavin mentioned, this talk is part of a webinar series on text analytics and corpus linguistics that the Sydney Corpus Lab is co-running with Lancaster's CAS this semester. Very briefly about the Sydney Corpus Lab, which is also located on Gadigal country in Sydney. It is a linguistics lab at the University of Sydney, which aims to promote corpus linguistics in Australia. And we have a range of resources related to corpus linguistics. So if you're interested, just check out the website, and you have the link there on the slide. I also want to acknowledge Chao Sun, who's here as well today from the Sydney Informatics Hub, who's helped develop these tools that I'm talking about today. So you'll probably hear from Chao later during the Q&A. I also want to acknowledge that some of the slides that I'm using today were in fact developed by the Sydney Informatics Hub, with whom I'm collaborating. So just to kind of start with a little bit of background. What am I talking to you about today? I'm talking about some new tools for corpus linguistics that we've developed as part of a collaboration in 2 Australian Research Data Commons funded projects, which are run by Professor Michael Ho from the University of Queensland, and that is the Language Data Commons of Australia, HAS RDC, and the Australian Text Analytics platform. For the text analytics platform, we're also working with ARNet, which is Australia's academic and research network, and also LADAL, the Language Technology and Data Analysis Lab at the University of Queensland is also involved here. So it's quite a big collaboration, both of these projects. And both projects contain a text analytics component, which we define here on the ATAB website as a suite of methods which enable data-driven research by extracting and analyzing machine-readable information from within unstructured text. And we do include corpus linguistics tools here, so we have a very broad definition. So our role, the Sydney Corpus Lab and the Sydney Informatics Hub, who I mentioned earlier, we're basically developing new text analytics tools as well as training for the analysis of text and language for linguists, but also other people in different disciplines in the social sciences and the humanities. So we have collaboratively worked on quite a few tools and projects, but today I will just do a very brief tool showcase on 2 of the tools. One of them is called the document similarity tool, and the other one is called the quotation tool. So I can't do a full demo or workshop, obviously, given the time constraints, but I'm hoping that what I'll show you today at least give you an overview of what these tools are and how you might use them. Very briefly, the document similarity tool basically allows you to identify and check similar texts for inclusion in a corpus. And the quotation tool allows you to find and extract speakers and their quotes from a newspaper corpus. So as you can see, I'm focusing on 2 tools that are perhaps particularly interesting for those of you who are interested in analyzing newspaper texts or other types of texts that might contain, for example, a large amount of duplication. And I'll talk about this later in a little bit more detail. But the reason for that is that, my own background in corpus-based discourse analysis has meant that I often have to deal with newspaper corpora, and these two tools are particularly useful for such kinds of text. So, very brief overview of my talk today. I'm going to start with some information on both tools because they share some common features in that they are both Jupyter notebooks. So I will talk very briefly about Jupyter notebooks. Then I will explain each of the tools separately. And hopefully, all being well, I will be able to show you a brief demo video. It's going to be very short. But even though the videos are going to be short, I'm hoping that they will provide you with a good general idea of the tools. And at the end, I'll summarize the relevance for corpus linguistics. So to start with some information on both tools, the code for both of these tools is written in the programming language Python, modified to run in a Jupyter notebook. So what is a Jupyter notebook? I'm going to spend a little bit of time talking about that now. These slides are adapted from Arnet's Introduction to Jupyter Notebook, and Arnet, as I mentioned, they're also part of this collaboration. So for those of you who already know what Jupyter notebooks are or who use them already, please, I do appreciate your patience with this brief introduction. And of course, you may help answer any questions that might come up later on as well, drawing on your own experience. So really briefly, Jupyter notebooks are a data analysis tool which allow you to do your coding in the cloud, so via the internet. They are freely available. They are very flexible. They generally save time. And what's not on the slide here, but they've also been praised for enabling greater transparency and also replicability. And that is one of the reasons why we're using Jupyter notebooks in these projects. So if you've never heard the term computational notebook before or Jupyter notebook before, you may not know what they are. So think about when we think about a notebook, maybe we think about someone taking notes, but here we're talking specifically about computational notebooks. They have been around since about the late 1980s, also known as a notebook interface. They're sort of like a mix between a word processor and the command line. So they allow you to have descriptions of what you're doing with your code as well as the code itself. So it's sort of like a virtual notebook environment for combining the description with the code in a user-friendly way. So it looks a little bit like this. This is a Jupyter Notebook interface. And you can see that there are some familiar things there. For example, the file, edit, etc. You've got some familiar things, some familiar icons underneath. And then on the right-hand side, you have some of the different types of cells that you get in a notebook. So you have cells that allow you to write texts, for example, about what you're doing with the code. And then you also have code cells, which is where you run the code, and you can actually adapt that code cell yourself, which makes them, adaptable tools. Okay, so we have the text cells and then the code cells as well. So they allow you to do what is called literate programming, pairing the functionality of word processing software with the concept of a code cell which contains executable code. So what you have is your text being sort of like your documentation, which accompanies the code. It means you have specific notes on what you're doing with the code. Or, those might also be explanations for others, for example, that you want to share the notebook with. And that means you have a record of the process that you undertook to get to your end result. What makes them different? They are both human readable because they describe what is being done through text, images, figures, tables, etc. And they're computer readable as well because they use executable code for performing analyses, in this case, text analytics, but also calculations, creating visualizations, etc. So they're sort of a mash-up of notebook, spreadsheets, statistics, visualization applications as well. Why are they called Jupyter notebooks? Very briefly, They were formerly known as IPython notebooks, but Jupyter is basically combining references to 3 programming languages, Ju for Julia, Py for Python, and then R for R. So you can use different programming languages with Jupyter notebooks. We are using Python. Okay, so going back to this previous slide, as I mentioned, the code for both tools is written in Python, modified to run in a Jupyter notebook. Now, where can you use these notebooks if you wanted to use them? We have made them accessible in the cloud through a web application called Binder. I will give you the specific links later on as well. This means that we have them available in a clean user interface with minimal coding required from users. In fact, you don't need to do any coding if you just want to use the tools as they are, but you can adapt the code as well. They are both interactive tools that allow you to display and analyze texts, as I will demonstrate in a second. Okay, so if you do actually want to use them and you want to get started with this later on when I give you the link, the first thing that you will come to is a sign-in screen. So you do need to sign in. It doesn't cost you anything, but you need to sign in order to be able to access the tools. So you can do this, for example, with your institutional provider. As in this example here, I've chosen the University of Sydney, which is my university. So you could choose the university with which you are affiliated, but there are also other options as well. So hopefully most of you should be able to sign in via this logon. Once you've signed in for the very first time, you will actually get to this screen, which is the Binder starting the repository. And you will get this kind of screen with all of the notebooks on Binder that we've developed. So this will be a very familiar page if you're looking at using some of the notebooks. I guess it's just important to point out, and I'm going to just show you this here, is that you will actually be hit with this screen first of all. The very first time you launch one of these notebooks, it will look like this, and this can go on for quite a while. So it can take some time. So if that happens, you know, nothing's necessarily wrong. It just does its thing. Be patient. Don't press any buttons. Make a cup of tea. You know, just wait. It usually only takes long the first time that you do that. After this process is completed, the notebook will load, and that is the same for both the document similarity tool as well as the quotation tool, and also the other tools that we have as well, which I will briefly mention at the very end. Okay, a final thing before I talk about the notebook specifically. There are some known issues that we're currently working on. So one of the issues is that we want to create more different ways of uploading corpora or data sets, because one of the widgets that we are currently using, it works, but it is a bit buggy, especially with larger data sets. So we are, if you come across this issue, we are already aware of it, and we are developing solutions here. There is a data size limitation, of course, especially with the online Binder version. So you can, in fact, also use this notebook offline if you know how to do this. So then that you might not have the same data size limitation. If you're doing it online, in general, the execution of particular code cells can also take a while, which is also dependent on the data size that you're using. So, you know, if you want to try it out the very first time, I just recommend you try the notebook out with, you know, 100 texts or something like that, just to you know, make sure you don't encounter any bugs the first time that you use it. Please also let us know, let the Sydney Informatics Hub know if you encounter any other issues that we need to work on. Okay, so let's look at the tools now, starting with the document similarity tool. So the motivation for developing this tool is basically, as I mentioned, my background in corpus linguistic analyses of newspaper corpora, which is, I think, something that a lot of people will share when you're working, especially if you're working in corpus-based discourse analysis. Obviously, often we analyze language in the media. One issue that we come across then is that newspaper corpora contain a lot of duplicates or duplicated articles. This can be the case within the same newspaper, if, for example, if you're collecting text from both print and online versions, but it can also occur across different newspapers where you have duplicated articles, either identical or just similar because of syndication, or perhaps newspapers are using similar press agency copy from press agencies. Such duplicates in turn can, of course, impact on statistical calculations, the retrieval of word frequencies, collocates, etc. Importantly, though, the extent of duplication really varies across news media landscapes. So it's not necessarily the same across countries, and that's something that you need to consider depending on the cultural context with which we are working. For example, in Australia, duplication is particularly problematic. So as a user coming to this issue, then my goal is that I want to be able to identify duplicates in my corpus and decide whether I want to retain them in the corpus or not, depending on my research question, depending on other issues as well. So the solution then is the document similarity tool, which basically is a tool that does identify similar documents in your corpus. It does that based on something called Jupyter similarity and a particular technique called Minhash, which I'm not going to talk about in detail here. We have got the link to the paper that explains this further. So I want to focus more on the output, what the tool does. So the notebook will provide similarity candidates for you. That means it will tell you, here are the articles that I identified as similar based on this Jacquard cutoff. So for example, anything with a cutoff larger than 0.5 will be identified as similar. The nice thing about this tool is that then you can decide whether you want to keep or remove these duplicates in the corpus. And you can do that by actually inspecting them, because it will give you the text side by side, as I will show you later on. So how do you do it? You can upload your text slider either as plain text file or also as a spreadsheet. If you do use a spreadsheet, you need a text name and text columns, as you can see here in the example. And if you want to upload a corpus, you can also do that. You can upload a zip file. One thing that's quite interesting in terms of visualization that is included in the notebook is that you can calculate, you can visualize the count of similar documents on a histogram. So you can actually see how many similar documents there are across the entire corpus. That, on the one hand, informs you about the extent of duplication in your data set. You could use that to compare different corpora in terms of how many duplicates they contain, or you could just get an idea of how much duplication there actually is in the data set that you're analyzing. Now, there are also other visualizations that the notebook allows you to do. For example, it can give you a visualization of pairs of documents that are similar to each other on a heat map, which I will show you later on in the little short demo video. The tool, as I mentioned, it identifies the candidates, the text pairs that it's identified as similar according to the cutoff. You can then see this in a table, and you can also save this information for future reference. The tool itself will basically recommend which of the two texts you should keep in your corpus and which one you should remove. And it does that based on text length. So if you can see here, for example, in row 1, you have text 8 and text 2. They're identified as similar. They have a value of 0.9961, so they're very similar. You can see that this text has a word count of 205 and this one has a word count of 200. So the tool will say, okay, we will keep the longer one. That's sort of the default. However, you can choose to use this default and just accept all of the tool recommendations, but you can also actually decide yourself what you want to do. And so this is the next step, where you can go through each of the pairs that is identified as similar. As you can see here in the example, you have the two texts and you have highlighted where the document is different. So you can then look at each pair and you can actually select an action, what you want to do. Do you want to keep this text? Do you want to keep this text, etc.? And you can thereby update the recommendations that the tool has made using your own human judgment. Now, this is obviously just a mock-up. As you can see, this is where the document is different, but I can show you in the video with a corpus. So at the end of this process, you have you can basically download the non-duplicated documents to your local computer. So you can save the non-duplicated text, or you can save the duplicated text as well, which means that at the end of this process, in essence, you have deduplicated your corpus based on the tool identifying the articles for you, and then based on you yourself reviewing these article pairs. You could, of course, then go and just kind of repeat the whole process all over again. For example, if you want to visualize the remaining similarity, or if you want to just double check for any remaining duplication. Okay, so at this point, I thought maybe it would be useful to just briefly show you the video. So I'm going to just stop my share for a second, and we can maybe have the video, and I'll try to talk you through it. And I think Emma's going to show that. Yeah, okay. So hopefully you can see that. Okay, so this is basically what the notebook looks like. You can see the code cell. You just basically start with importing the document similarity package just by running this cell. The next step is also fairly simple, which means you just load the data. And again, you do this by running this particular cell, which gives you the upload widget. You then upload your corpus. In this case, it's a diabetes news corpus. It takes a little while for the corpus to load, so just wait and be patient. You can see here there are about 577 files loaded. I can have a look at displaying some of this text. I can decide how many lines I want to look at, say 15 here. I've just changed the number in the code. And that's just kind of to look at it to see what it looks like. And the next step is really the parameters for the duplication. So I can do it based on words, or I can do it based on n-grams. I can also change some other parameters. For example, I could say, I want to exclude punctuation. And I can change the similarity cutoff here from, say, 0.5 to 0.6, as you can see there. So once I've set the parameters, I just run this code cell. That's setting the parameters, and then I just actually calculate the similarity. Again, just running the code, and you can see it's just going through these steps, and it's identified 86 pairs of similar documents in the corpus. So you've got 86 pairs that you then can look at. Now you can show them, look at them on this histogram, so you can see how many texts there are with respect to particular similarity score, just as a visualization, as I mentioned, about the similarity. And you can also do different kinds of visualization. This is optional, you don't need to do it, but you can look at a heat map as well. So for example, I could say, give me the top 20 most similar article pairs on a heat map with their scores. And that's what it will do, which you can see here. This obviously may not always be of interest, and it can take a long time if you have a huge amount of text, but it allows you to see which article pairs have a similar similarity score as well. Okay, so if we move on, we can then look at the texts that are identified as similar. So you have them all here in the table, and then we can display them, as I mentioned early on. So you can see here, here are the two texts. They're different in the beginning there. I can just review the difference. I can then select my action. What do I want to do? Keep the left text, keep the right text, keep both. And I can update the selection there in the tool. And I can then go through each pair and do the same thing for each pair. So I can just go next pair, look at it, and always sort of think about the action that I want to take with each of these pairs, update the selection, etc. And then this is already brings us to the end. So at the end of this process, as I mentioned, you can simply save your duplicated or non-duplicated text by clicking on the relevant button here. depending on what you want. So, I mean, I recommend you save both the duplicated and the non-duplicated text, and it will give it to you here as a zip file. Okay, so that's kind of, I know it was a very kind of whirlwind sort of video, very, very quick, but that's just for the purpose of this talk today. So let me go back to my content slide. Okay. Okay, so if you want to know more about the document similarity tool, we do have a blog post where we describe the features of the tool, and we're also in the process of developing online help pages, so that should help you to do your own analysis independently later on. Now, please hold your questions for the end, because I want to go on straight on to the quotation tool. So this is the second tool that I want to briefly show you today. What's the motivation here? Similarly to the previous tool, the motivation comes from corpus-based discourse analysis, where often newspaper data are the source of data. So most of you will know that in corpus-based discourse analysis, the newspaper corpus is often treated as sort of like a holistic or aggregate in terms of the content of individual articles. But we also know that a newspaper article will contain text in the institutional voice of the newspaper, but it will also contain text that is quoted, attributed to sources through direct or indirect speech. So my goal as a user or as a corpus-based discourse analyst is then that I want to be able to identify the sources, who is cited, and I also want to be able to identify a corpus or extract a corpus of quoted content. And this is sort of a similar idea that you have in the Click Dickens web app for literature, for example, a completely different text type, which also allows you to some extent to consider quotation. Okay, so the solution for this problem then is our quotation tool, which is a text analytic tool used to extract quotes from a newspaper text or a corpus of such texts. It extracts the speaker, the reporting expression, and the reported or quoted proposition. The code for the quotation extraction comes from the gender gap tracker team, modified to run on a Jupyter notebook. And please, if you have any questions about the code for the extraction of quotes, please have a look at this article there. It's cited on the slide. There's also additional information, supplementary information. In addition, the quotation tool also uses natural language processing tools called SPACY and NLTK, both of which come from the Python ecosystem and allow you to process and extract information from the text. So I'm just going to give you a little bit of information about the extraction of the quotes. So as I mentioned, this is based on the gender gap tracker team, Maite Tabuada's team in Canada. So this comes from the analysis of Canadian newspapers originally. Here the code uses SPACY's dependency parser to identify constituency structures in sentences, because you can see here that, of course, reported speech has a particular kind of structure. But in addition, it also is based on a list of verbs that are often used in quotations in newspapers. And I will show you some more examples later on. The interesting thing as well is that the code also allows you to identify what is called floating quotes. And this is all from the reading that I cited earlier. So a floating quote would be all of these examples in bold here, where we have a quote, but we don't have like a reporting expression because that has been used previously. So the quote is like floating on its own, but it is still a quote from the previous speaker. So the tool uses particular kind of notation and patterns to identify something as a floating quote. And you can see some examples. As I mentioned, you can always go and read that article where it is explained in more detail. So from a linguistic perspective, I thought I'll give you a very brief explanation of how the tool might deal with different lexicogrammatical resources. Now I've used terminology from systemic functional linguistics here, but it doesn't really matter. So we're looking at different ways in which information is attributed to people in the news. So one way is through use of according to. as in the first example, about 40% of Mexican adults are overweight and 30% obese, according to the health ministry. We also have direct quoted speech, like most Australians don't get enough folate, Dr. Fenwick says, or indirect quoted speech, who says most of us need 7 hours sleep at night. We can also attribute sort of more mental phenomena to people. So, for example, fears. Again, we can do that directly. It's soon to be unemployed officers' fear the voice of millions of Australians will be lost. And we can do that indirectly. Again, the people who think we have to turn Adelaide into a second-rate imitation of Sydney. And then finally, sometimes we use words like highlight to attribute that this information comes from someone else. So now research by the Royal Melbourne Children's Hospital has highlighted the amount of TV children are watching. So some comments on how the quotation tool seems to deal with these. So cases with according to are identified by the tool. Generally, when there is direct quotation marks, the tool handles this quite well, and these cases should be captured regardless of whether you're using verbal, mental, or material processes. Where quotation marks are not used, the tool really wants to avoid identifying too many false positives or making too many errors. And this is where the list of communication verbs comes in. So we have a list of, I think, 257 different verbs that this code from this team has used. And it would basically identify instances that use one of these forms. And so you can see, for example, it does include mental processes like think. It also does include things like highlight and highlighting, etc. But on the whole, it would only identify instances then where no quotation marks are used if that process is on that list. So that tool is not going to capture absolutely every instance, and it will also make mistakes. So you can expect some quotations to be missed, some could be wrong. It can also find it difficult in identifying the speaker in cases with sort of relative pronouns, especially if it is difficult to link the relative pronoun with the antecedent. So you might have something like who identified as the speaker or as the source. So you might have to do more work then to identify, well, who is the antecedent. So the quotation extraction, which I just explained, comes from the gender gap tracker code, but we have added identification of entities using Spacy's built-in entity recognizer to identify the named entities both in the quoted content as well as in the speaker. So you can see that in the example. In the first example here, we have the speaker element, expert Anna Pauls from Massey University. And you can see that Anna Pauls is identified as an entity. She's identified as a person, and her organization, Massey University, is identified as an organization. So we have her affiliation identified here. In the second example, again, we can look at the speaker, Nationals leader David Littleproud. He has been identified as the speaker. His affiliation, which is a political party, has been identified as an organization, and he himself has been identified as a person. So that's within the speaker. And we do the same within the quoted content. So here, Australians has been identified as NORP, which stands for nationalities or religious or political groups. And then Mr. Morrison has been identified as a person. And all of this is within the quote. So we have the named entities either in the speaker or in the quote. We don't have it in any other aspect of the text. Again, this is, an automated tool, so it won't be fully accurate. So not all entities may be found. Some entities may be misidentified, or the stretch could also be wrong as well. So don't expect this to be 100% accurate. How does it work? So you specify the named entities that you wish to include. So these come from the Spacey model. So for example, person is people, NORP is nationalities, etc. FARC is buildings, airports, ORC are like companies, agencies, institutions. GPE and LOC are both to do with different types of locations. And you can modify this. You can use different ones as well if you want to. The quotes will then, along with the metadata, be stored in a table format, which means you can look at them. So you can actually inspect the extracted quotes and the associated data, such as who is the speaker, where's the location within the text, and so on. The notebook also gives you a little interactive tool to display and analyze them as well. And then finally, you can save and download the extracted information, again, in a spreadsheet, and you can do additional analysis in the spreadsheet, for example. The interactive tool, the notebook basically allows you to identify, for example, who are the top entities that occur as sources. So who are being cited. You can also identify the top entities that occur in the quotes, so who are being talked about. That's one of the things that you can do in the tool itself, or if you wanted to, you could do this in the downloaded spreadsheet as well. It is really up to you and your preference. Now, obviously, the advantage of this is that it takes minutes rather than hours to extract the quotes from a large number of texts. But as I said, the disadvantage is one of the disadvantages might be sort of the accuracy level. So this is what the downloaded spreadsheet looks like in essence. I've hidden a few columns, as you can see, but basically you will see that you have a column where you've got the quote, a column where you have the speaker, you have a column where you have the verb or other reporting expressions like according to. You have the quote type, which is what I introduced earlier on when I explained the quotation extraction. This comes from the gender gap tracker code, and also whether it is a floating quote or not. So if it says false here, it means it is not a floating quote. If it says true, it means yes, it is a floating quote. So you can then, of course, use the spreadsheet functionalities to do further filtering and sorting. So, for example, you could say, well, give me everything that is cited using the verb said, or you know, other verbs. You can look at, you know, give me all of the floating quotes, or give me all of the according to quotes, and you can use that sorting mechanism that you would use in a spreadsheet to do more a qualitative analysis if you wanted. Another thing that you could do is you could extract that whole quote column here, and then you would have a corpus of quoted speech, right? The speech that, or the propositions that occur in the direct or indirect quoted speech that are identified at least by the tool. And you could do that and could do further analysis with that kind of corpus. So for corpus-based discourse analysis, this can be useful because it allows you to look at who the sources are, you know, whose voices are heard, what sources are cited, whose truth gets told, and how are these voices or sources actually identified? Is there, for example, any kind of gender or other bias, like in the use of titles or reference to parental roles or other things? How are the quotes integrated, for example, through direct speech, indirect speech? Do we get to hear or experience what the sources said directly, or just a paraphrase, a summary, or an interpretation by the journalist? As I mentioned earlier, it could be useful to look at particular reporting expressions. So, for example, some verbs associated with negativity or positivity, like in the example here, about 46% of Australians admitted they ate whatever they wanted, whenever they wanted. Now, one could argue that it is a privilege to be able to eat whatever you want, whenever you want, but it's not presented here as a positive thing or a privilege. It's presented here as something negative, right? Something to be admitted to. And that's just one example. There are other verbs that carry sort of negative and positive meanings, and you could look at the propositions that are associated with these verbs. You can also look at reliability, as it's really well known that reporting expressions differ with respect to the kind of positioning according to reliability, like claim is more doubtful than, say, a neutral verb like said. So you could compare which kind of speakers and which kind of propositions are attributed using said as opposed to claim. So these are just some examples and ideas. When or how might you use this tool? If you have too much data to analyze manually, you want to maybe get a quick overview of trends in data sets. You could compare two data sets here. You should really use it carefully and critically, be mindful of the accuracy, and also be mindful of the type of text. So it has been developed for newspapers. Maybe it works for other types of text that include quotation, but we cannot make any statements here regarding accuracy. for other types of text. And I would also really suggest that you complement the use of the tool with additional analysis for qualitative insights, for example, through the spreadsheet or from the visualization in the notebook. And of course, you can always check back against the corpus or text itself for human oversight. So again, would like to show you very briefly a demo. So I will stop my share and Emma can share the video and I'll talk you through it. Okay, so here you go. You can see it's very similar to the other one, which means you start with the setup, just basically importing the quotation tool by running this little code. And here we are. So it's loading it. It's finished loading it. Again, the next step is similar as well. We have our upload widget, which we get through running the code. We upload the same corpus, the diabetes news corpus, a corpus of Australian diabetes news. And again, it takes a little bit of time until the progress bar appears and until it tells you it's loaded. So we've got our 577 texts again. The next step is obviously to look at the text with the preview before you then go to extract the quotes, which is the next bit here. There's always information which you can read or should read because it gives you more information about what's happening. Here you can specify your named entities in the code. You can specify other things by changing the numbers of the code itself. So it's all fairly straightforward, as I mentioned, with the location being one of the default entities. Now it takes a while. You can see I've deliberately left that so you can see how long it takes. Obviously, you can imagine that if you have a larger data set, it will take longer. This is 577 newspaper texts. You can also see that at the end of this process, you will end up with a table that gives you different kinds of information. This is where that color block comes up. It actually tells you more about what are the column headings in this table that you're going to see, what do they actually refer to? And this is an example where you can include explanation alongside the code. So here's the result. You can see that in a table. Now, obviously, you can see the information there that I've already shown you on a slide earlier. So like the quote, the speaker, speaker entities, verbs, etc. If we scroll down and scroll to the right, we can see that it also gives you the quote type, again, as explained earlier, here SVC, and whether it's a floating quote or not. So that's all very similar to what I demonstrated earlier on. Here's the interactive part of it. So you can actually visualize an example text so that it gives you a little bit more information about what has happened here. You can check the accuracy. You can see it's visualized and it tells you who's been identified as speaker, as quote, as person, and the entities. So whatever you want to visualize, you can visualize this per individual text. It's just a good check for you to see what the code actually did and also the extent of sort of errors, for example. And then finally, we can do a bit of analysis around the top speakers or top quotes. Either I'm just doing everything together here. Who are the top speakers? Who are the top people mentioned in the quoted contents? I'm going to do it with all of the corpus, so all of the text. And you can see we've got the top people who are quoted, of course. Who occur in the quoted content, I should say. The top 10 quote entities, very Australian centric. And then you have the top 10 speaker entities. So these are the people who are cited, again, quite Australian centric. And you also have the quote entities. So this is from the entity recognition, whether they're organizations or people that are being talked about. And the same in the speaker. And of course, you can see people are cited the most. Again, it's fairly quick. Just to give you a bit of an idea, at the end of this process, you can download the results as a spreadsheet. So that's where you can then do further analysis using the functionality of the spreadsheet. As you can see here, it has all of those different columns that I mentioned to you. So that hopefully, again, I know it was a quick, very quick demo, but it hopefully gave you a bit of an idea of the tool. Let's briefly go back to the slides. Okay, so again, if this was too quick for you, we have a blog post where we describe this functionality. And again, we are in the process of developing online help pages. So let me conclude by talking about the relevance of these tools for corpus linguistics. As I mentioned, they were motivated by the need, particularly for those corpus linguists who work with newspaper data or other kinds of data where you might have, for example, duplication. So the document similarity tool is a tool for helping you with corpus construction and analysis. The use of this tool really depends on your research question. So, for example, you might actually be interested in retaining duplicated content in your corpus because maybe you're interested in identifying dominant discourses, repeated discourses. You know, we could say that a discourse is dominant if we take the point of view of the wider audience, like no matter which newspaper you read, you will encounter this discourse. We could say then maybe it's a dominant discourse. And if we're interested in that, we probably want to retain the duplicates. But maybe we are just interested in unique discourses, in which case we probably want to deduplicate our corpus. Really depends. Another question to ask is, well, are we interested in looking at the newspaper corpus as a whole without worrying about articles from particular newspapers, in which case, again, we can just deduplicate and it doesn't matter which article we retain amongst duplicates. But if we're interested in comparing different newspapers, duplication is a bit more complicated because if we're taking an article away from a newspaper, then we have no longer collected all of the articles from that newspaper, if you see what I mean. So again, it depends what is your research question. So, you know, the tool allows you to keep or remove articles that are duplicated either within newspapers or across newspapers. It just depends how you use the tool, because you could just upload the data per newspaper if you only wanted to remove duplicates within a newspaper, but you wanted to retain duplicates across newspapers. So you would just use the tool per newspaper rather than per whole corpus. Hopefully this makes sense. This is all just to say that think carefully about what you want to do with the corpus. You can also, of course, have different versions of your corpus. You could have one version that is deduplicated and another version that is not. Okay, moving on. What about the quotation tool? I think it should be fairly obvious that it has some applications for corpus-based critical discourse analysis in particular, because it really can be a starting point for answering a range of questions like who is cited, what types of quotes are the most frequent, what type of reporting expressions occur, how might this vary depending on aspects such as gender or other social groups. How are different groups of speakers linguistically represented? What kind of information occurs in the quoted content? And is there any imbalance or bias observable in any of the above? So again, just a starting point. We want to do more qualitative analysis after we've used the tool. I should again want to point out that you should use it carefully and critically, and keep in mind that it's not as accurate as human analysis, so it has its limitations. Okay, so I've only talked about the quotation tool and the document similarity tool today. We do have a few other ATAP tools that might be of particular interest to some of you. So we have a semantic tagger notebook which annotates all tokens in a corpus with semantic tags, with thanks to Paul Rayson. We also have a keywords notebook, which retrieves keywords for multiple corpora. Also, again, thanks to Paul Rayson. We have a discurses notebook for analyzing interactions in conversations and discourse transcripts, with thanks to Dan Angus. Currently, Chao Sun and the team are working on a tool called Juxtorpus, which is helping you to slice corpora according to different features and aspects of the data and compare them. So that's very much a work in progress. So stay tuned. These are all available through the Australian Text Analytics platform website, so atap.edu.au. If you find any of the tools of interest and you use them in your teaching or research, please do cite it, because it obviously helps us with the projects and trying to get continued funding as well. So just to conclude, one of the motivations for developing research capacity in text analytics is that there's obviously an increasing interest across the social sciences and humanities in the computer-based analysis of language data. So we have interdisciplinary fields such as computational social science and digital humanities. At the same time, we can see that there's still a need among students and researchers for training in text analytics and also access to non-commercial tools. We see in this project, we see notebooks as a user-friendly way into text analytics and coding, which also enable greater transparency and replicability. And we also want to use this opportunity to give our students in the humanities, as well as other disciplines, new expertise for work within and outside academia. There are some links here on the slide, including to the Gender Gap Tracker GitHub page, the document similarity tool. You can try out the notebooks by accessing GitHub from the Australian Text Analytics platform here. And here are also the references relating to some of these codes that I mentioned. And I want to say thanks for the funding that we received and that enables us to do this work. And I want to thank all of you for being here and listening to me talk. And I hope you found this interesting. Thank you.
Thank you very much, Monika. That was so interesting. I can see lots of clapping hands floating